Assalamualaikum. My name is Muhammad Adil Aiman and my number metric is CE220106, and today I will explain the question 1. Find fx and fy. So for the one Roman is fxy is x power of 2 minus 1 multiplied with y power of 2. So for find the fx, uh, we must differentiate uh, the x and the y is constant. So first we solve this question, and then we get this form. So we differentiate the question, and we get the fx is 2x multiply with y plus 2. And then for the fy, differentiate y with x is constant. So we calculate and we get the we differentiate, we get fy is x power of 2 minus 1. Okay. Alright, for the manual, we must declare the symbolic variable x and y, okay, like this. And then we put the command f x power of 2 minus 1 multiply with y plus 2 to define the function of xy. For the line 4 is we put the command fx, differentiate fx, and then fy is differentiate fy. So to compute the partial derivative fx and fy. And then for the line 7, we put the display result to get the answer. For first command is we put the display fxy with char command f to display the question. And then we put the command display fx with char command fx to display fx, and also display fy with char command fy to display the fy. And then we uh, running it, and the calculation is uh, we get here. So fx, we get 2x multiply with y plus 2, and fy x power of 2 minus 1. The answer we get here is same like we get in the manual. Okay, that's all for me. Thank you.
Assalamualaikum and hello. My name is Haikal Iqmal bin Abdul Hadi. Number matric is CE220093. So I would like to explain about question 1, Roman number 2. So our question is fxy is equal to exponent power of x plus y plus 1. So the first thing first, we need to differentiate the equation, and we need to make sure that fxy, the first one is we need to make sure that fxy with the respect to x, and make sure the y as a constant. So the final answer we get the fx here is exponent power of x plus y plus 1. This is for the fx. And then for the fy here, the same method we use, differentiate the equation, and then we need to make sure that fxy with respect to y, and then make sure that x as a constant. The first one is y as a constant, and the second one is the y as a constant. And then we get the second one is x as a constant. So we get the answer for fy is exponent to power of x plus y plus 1. So I will explain about the question 1 Roman 2 for our software. We use MATLAB, and then the first line is we need to define the function of fxy, and the second line is we use sim x and y. And here is the equation for the line 3. And then for the line 5, we complete the partial derivative fx and fy. And then for the line 6 and 7, line 6 we just change the fx and fy. So the partial differentiate the fx, and for the line 7 we differentiate the fy. So for line 6, partial derivative of f with respect to x, and for the last line is we differentiate of f with respect to y. So we got the answer here same with the calculation, manual calculation here. So this is the fx, and this is the fy. So for the overall, this code show how to define a symbolic function in MATLAB and compute its partial derivative with respect to x and y using the differentiate command. So that's all from me. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay, my name is Muhammad Zaki Izzat bin Osman, metric number CE220075 and from group 9. Okay, today I will explain about question 1 A and part 3 Romans. Okay, I will explain in detail about MATLAB calculation and also the theory calculation or manual calculation. Okay, in this part, it's a MATLAB calculation. This MATLAB could define a symbolic function fxy, exponent negative x, sin x plus y, and compute its partial derivative with respect to x and y using the syms and diff commands. Here is a step-by-step explanation of what the code does. Okay, and in the first line, declare two symbolic variable x and y using the syms commands. And second, the second line define the function fxy as a exponent negative x sin x plus y using the exponential function exp and trigonometric function sin. Okay, after that, the third line is compute the partial derivative of f x y with respect to x using the difference command and assign it to the variable fx. Okay, the fourth line compute the partial derivative of f x y with respect to y using the difference command and assign it to the variable fy. Okay, overall this could show how to define a symbolic function in MATLAB and compute its partial derivative with respect to x and y using the difference command. In this case, the function is fxy equal exponent negative x sin x plus y, and its partial derivative with respect to x and y are computed. Okay, and this is a manual calculation for this question. The result same. The result manual calculation same in the MATLAB calculation. Okay, that's all from us. Thank you.
Hello, my name is Muhammad Afiq. So I go from group 9. So I will explain question 1B, 1 Roman. The question is evaluate fx, fy, fz in terms of xyz. So let's see the solution for manual from my group. So the solution is, as you can see, u in the row, u power of 2 plus y plus 2t x plus y minus 2z power of bracket, close the bracket, power of 2, and you can see, and the final x2 plus y2 plus 4z2 plus 2xy minus 4xz minus 4yz plus fx minus 2y minus z. So from this one, we find partial derivative with respect to x. Yeah, we treat y and z as constant and differentiate the expression with respect to x. And then you can see this one bracket x plus the bracket x power of 2 plus 2xy minus 4xz plus fx. So we find the fx equal to x plus 2y minus 4z plus 5. We find this one to partial derivative with respect to y. We treat x and z as constant and differentiate the expression with respect to y. After that, you can see from y, open bracket y, and close the bracket, y power of 2 plus 2xy minus 4yz plus 2y. So fy equal to y plus 2x minus 4z minus 2. And we find the partial derivative with respect to z. We treat x and y as constant and differentiate to expression with respect to z. And final step, we search for fz. Yeah, z 4z power of 2 minus 4xz minus 4yz minus z. Fz equal at z 8z minus 4x minus 4y and minus 1. The final answer for evaluate fx, fy, and fz. So from the final solution involve finding the partial derivative of the given expression with respect to x, y, and z, which are 2x plus 2y minus 4z plus y, 2y plus 2x minus 4z minus 2, and 8z minus 4x plus 4y minus 1 respectively. So that's all for manual calculation we explained. Thank you. So we're back with the software simulation. So which we're using the software Maple. So first of all, the question is fx u2 plus v 2t, and we enter the maple will be auto generate value of u, v, and t. So we don't insert the u, v, and t because of the maple provide the u, v, and t. So after that, we research for x, y, and z. So as you can see on this, if you want search fx, you just delta per delta x. So and for fy, delta per delta y, and fz delta per xz, delta z. So and you enter. After you click enter, and the maple will be auto generate, and the answer will be show in the maple on the screens. Yeah. So on the manual and software simulation is the same, so it's not have different, the same answer we got it. So I think that's all from software maple. Thank you.
For the question today, we want to calculate df of the dt. The function given is f u v t is equal to u squared plus v plus 2t. We differentiate df over du. From here, we get 2u. For the second is df over dv, we get 1. Df over dt is equal to 2. Okay, for the first function here, v equal to x plus y minus 2z. We differentiate all the function given with respect to x, y, and z. For the first one is du over dx, we get 1 here. Du over dy, 1. Du over dz and minus 2. Okay, for the function for v, v is equal to 4x minus 2y minus z. We differentiate dv over dx, we'll get 4 here. It is 0, 0. Second is dv over dy.
is equal to minus 2. dv over dz get minus 1. Okay, for the third function is x is equal to 2t. Differentiate dx over dt is equal to 2. y y for the fourth function is y is equal to 2t t squared. For the dy over dt, we get 2t. For the last function is z is equal to 5. We differentiate dy over dz, we get 0 because this is not have a function here. Okay, for the step 2, we know the formula we get to get the df over dt. Okay, for the first one is we get the formula. We get the function for the question is 2u 2u 2 plus 1 bracket negative 40 plus 2. For the uh, for the simple mathematical event, we get 4u minus 40 and plus 2. Okay, for the next derivative, we get from here u here. We put to the replace the u here, so we get 4 bracket x plus y minus 2z minus 40 plus 2. We expand here, we get 4x plus 4y minus 8z minus 40 plus 2. So we know that x is equal to 2t. We put 2t here. Y is equal to t squared and 5. We know that z is equal to 5. 5 here. And so for the expand here, we get a 40 plus 4t squared minus 40 minus 4t plus 2. 40 for the final answer is 4t squared plus 4t minus 38. Okay, for the software calculation is we get for 2 bracket t squared plus 2t minus 10 bracket 2t plus 2 plus 10 minus 40. We expand here, we get 4t3 plus 4t cubic plus 12t squared minus 36t minus 30. Okay, from here, we differentiate and we expand here t squared plus 2t minus 10 bracket 2t plus 2 plus 10 minus 40. Okay, we expand here, we get 2t squared plus 4t minus 20 bracket 2t plus 2 minus 4t plus 10. Okay, we expand here and we get 2t squared plus 40 minus 20 bracket 2t plus 2. Okay. 4t cubic plus 12t squared minus 36t minus 30. For the final answer is 4t squared plus 4t minus 38. Okay, that's all from me. Thank you.